Another type of realizable filter are digitally implemented filters. So digitally implemented filters, you would take a analog input, put it through an analog digital converter, and then you would use some kind of computer chip, some kind of other system that you can program to implement your filters in the digital domain. You'll get a digital output, and then eventually you would put it back through an analog to digital converter. The pros of this is that the accuracy of this will just depend on your computer word length, your quantizing interval, and your ability to sample the signal so that you reduce the aliasing. The other great things about digitally implemented filters is that they're less affected by things that analog filters are affected by. So analog filters, you're building all these components. Maybe some of them are being built in a fab or a chip process, and those have problems sometimes. So you might have some variation in analog components. Analog components tend to be more susceptible to changes in temperature and may drift over time as that analog device changes. But the digitally implemented filters are much less susceptible to any of these things, as they're usually just put through some digital domain series of sums or etc. That don't get affected by those on-chip components. You can also rebuild digital filters easily. So if you need to change the filter, it can be rebuilt digitally. It's just a program that you need to change. It also is often easier to realize the high order filters. So recall our discussion of the Butterworth filter. As this Butterworth filter, as this n gets higher and higher, we get even closer to the ideal case. And so you can realize high order Butterworth and other types of filters more easily in digital filters. Digital filters are a bit beyond the scope of what we will be discussing most in this class. If you want some more information, this is a classic text, The Discrete Time Signal Processing by Oppenheim. So I would encourage you to take a look at that if you're interested in building digital filters.